Hello students, welcome to my video again. So this is of class 10 Vedanta Axel optional math. So I forgot to mention here optional math. This is optional math, okay? OPT math. Optional math. So we are studying coordinate geometry. The large volume of questions will be asked from this coordinate geometry part, okay? So in the first coordinate geometry, we will be in the first part of the coordinate geometry, we will be reading about the angles between two straight lines, okay? So whatever are the trivials, the formula that you have read in the class 9 also, that will also be embedded in this class 10, okay? That will also come in handy in this class 10 optional math. So those formula will be used in the class 10 also. So you have to reminisce all those formula that you have read in the class 9 also. You have to remember, okay? Otherwise, there will be a missing link. You will not connect the dot when trying to understanding the questions, and while you solve while you try to solve the problems, you will just your mind will just get diluted in the what we call that smoke, okay? So first what you do is angles between two straight lines. First we are going to discuss about the angles between two straight lines, then after condition for parallelism of two lines. So in what condition two parallel lines will be, at what conditions two lines will be parallel, and condition for perpendicular of two lines. So we are going to discuss about these three, okay? Maybe with a suitable example, okay? Now let's first discuss about the angles between two straight lines. So angles between two straight lines, here I have considered AB and CD, two straight lines. When they intersect with each other, let's the angle made between them be theta, okay? Theta is the angle made between these lines when they intersect at this point, okay? So one will be acute and another will be obtuse. So I have considered AB line. So AB line, I have considered this. The equation of line AB is y equals to m1x plus c2, and line CD equation is y is equals to m2x plus c2. This is line CD equation, and this is line AB equation, where this m1 and m2, this m1 denotes the slope of line AB. AB's the lines AB slopes, okay, that represents m1, and m2 represents the slope of line CD. So if you know the slope of both lines, then you can find the angles between those lines, okay, these two lines, by using formula theta equals to tan inverse under bracket plus minus m1 minus m2 1 plus m1 m2. So this is the formula for to find the angles between two intersecting lines, okay? So you have to remember this formula. So while calculating this, when you need acute angle, the theta must be positive, but when you need obtuse angle, that theta must be negative. I'll try to show with the appropriate examples. So for that, I have one questions here. For example, let x minus 3y plus 2 is equals to 0 and x plus 2y is equals to 8. This be two lines, and okay. So I'll go into this question, okay? So without further delay, now I'm going to write this. If you need this, you can take notes of this, okay? You will be needing this formula, while solving this. So we are going to find the angles between these two lines. Okay, we're gonna find the obtuse angle also and acute angle also. So let's move into that without any further delay. Okay. Okay, so find the angles between two lines. So given two lines are, one is this and another is this. Okay, so find the angles. So it means we have to find both the obtuse and acute angle. So let's start this. Then if I want to make you understand this more with diagrammatically, then what you do is just, we have one line, x minus 3y plus 2. You consider this 2 is equals to 0. You consider this I. And another line we have x plus 2y is equals to 8. You consider this double line. Okay, these are the two lines, and you have to find the angle between those lines, that is represented by theta. So what you can do is, here from I, so from I, in I we have x minus 3y plus 2 is equals to 0, or just try to make this in the form of, just every equation you just try to make this in the form of y equals to mx plus c. It means you have to make this y alone. So x plus 2 is equals to 3y, or 3y is equals to x plus 2, y is equals to x by 3 plus 2 by 3. Okay, I forgot to write here x. So let line I slope be represented by m1. Okay, when you compare this equation with this y equals to mx plus c, what you get the value of m here? 1 by 3. X by 3 means you will get the value, the coefficient of x will be 1 by 3. So slope of line I, that means m1. I have represented the slope of line I by m1, that will be 1 by 3. Okay, similarly I discovered, or I got the value for m1, the slope of line I. Similarly, you can also get the value of, now, from double I, line double I. So there is x plus 2y is equals to 8, or 2y is equals to minus x plus 8. So I'm trying to express this form, this equation in the form of this y equals to mx plus c here also. So this one, I think this will be more easier and effective. Or when you compare this with y is equals to mx plus c, you will get the value m minus 1 by 2. Or if you find this more difficult, then you just write here minus 1 by 2 x plus 2 for the 8. So I think this will be more easy for, this will be the slope. Okay, so slope of line double I is equals to, so slope of line double I represent that slope by m2 is equals to minus 1 by 2. So after getting m1 and m2, now apply the formula. Now we know theta equals to tan inverse plus minus m1 minus m2 whole divided by 1 plus m1 m2. Okay. Now you just put the respective value for m1 and m2, and then you just simplify it. Okay. So the positive value for this simplification, the positive value for this simplification, it will gives you the acute angle, and the negative value gives obtuse angle. So let's move into the next step. Okay, now now just put the respective value of m1 and m2. Tan inverse plus minus m1 we have 1 by 3 minus m2 we have minus 1 by 2 whole divided by 1 plus 1 by 3 minus 1 by 2. Okay. Or theta equals to tan inverse, you can use the calculator, 1 by 3 plus 1 by 2, 1 minus 1 by 6, or theta equals to tan inverse plus minus, okay, you can use the calculator directly, that will be more efficient. Okay, when you calculate all this, when you simplify and calculate all this, you can use calculator, the value will be plus minus 1. Okay, in this case, for acute angle, you can take a positive sign. For acute angle, take positive sign, which is theta is equals to tan inverse 1, which is 45 degree. Yes, for obtuse angle, you take negative sign, which is theta equals to tan inverse minus 1. So when you just use calculator and write tan inverse minus 1, you will get the answer minus 45 degree. So actually that minus 45 degree means, this minus 45 degree means you have to subtract this 45 from 180 degree. 180 degree minus 45, that means 135 degree. Okay. So if there is minus 60 degree, if there pops out minus 60 degree in the calculator while you calculate, then you should not write minus 60 degree. Instead of writing minus 60 degree, you have to subtract 180, that 60 from 180. Okay, so whatever the degree comes in minus, you have to subtract it from 180. That will give you obtuse angle. That is what mean by that. So when you write when you calculate tan inverse minus 1 in the calculator, you will be given minus 45 degree, which means 180 minus 45, that is 135 degree. This is acute angle and this is obtuse angle. And there is also one way to find the slope. If you find this difficulty to make into this form, y is equal to mx plus c, you can also use another method, that is the method for finding the slope, that is slope is equals to minus coefficient of x divided by coefficient of y. If you can remember this, then it will be easy. Okay, so most of the students, they will just forget this formula. That's why I have more often I would rather tell them to express this form in the form of this y equals to mx plus c, So it is the most easiest, and you never have to remember this kind of formula. Okay, so if you find easy, if you find easy this way, you can use this way, or I prefer you to use this way, y is equal to mx plus c, and you compare with that, and you will get the value m. So m will be the whatever value comes when you compare this in the form of this. Okay, whatever value of m comes there, that will be the slope of that line. And I think that is the most effective way to find the slope of the any line. Okay, so this one, if you find this one effective, then you can use this formula. Okay, so why do you use this formula? People often forget the formula, that's why. Okay, now we'll discuss the condition for parallelism and condition for perpendicular or orthodox. We can also call it orthodox. Orthodox means perpendicular. Okay, let's dive into that. Okay, now so let's discuss about condition for the parallel lines. Okay, so condition for parallel lines. So for the condition for parallel lines and the coincident, either you will be mentioned either parallel or coincident. It means the same. Parallel lines and coincident, the condition will be the same, but it generally doesn't mean the same. The meaning is not the same, but the condition for these two are same. The condition for parallel lines and condition for coincident. What happen is that when lines are parallel to each other, then at that moment, when these lines are extend, they will never meet each other. So in that case, so if the lines never intersect, then there will be no angles formed between them. So in that case, theta will be 0 degree. So we know that in case of parallel lines also, in case of if one line is coincident, means it is in the same line as the first line, it just coincide with the other line. In that case also that theta will be the 0. And we also know that theta is equals to tan inverse plus minus m1 minus m2 divided by 1 plus m1 m2. In this case, now we will only focus on this case. So in the case of parallel lines, this theta will be 0 degree. Okay, so this is tan inverse. If I move this tan inverse to the other side, that will become tan. Okay, so this I can write here plus minus m1 minus m2 divided by 1 plus m1 m2. Now tan 0 degree means it is 0. Plus minus m1 minus m2 divided by 1 plus m1 m2. So when something multiplied to 0, it literally becomes 0. Yes, 0 equals to plus minus m1 minus m2. So you can consider this, take positive sign, then what happen is 0 equals to m1 minus m2, or now you move this m2 to the other side, it becomes m2 equals to m1, or you can also consider this m1 equals to m2. So this one m1 equals to m2 is the condition for parallel lines or coincident lines. So for the condition for parallel lines, this is the condition: m1 must be equals to m2. So if two lines have the same slope, that means those lines are parallel or coincident. So now you know how this relations was derived. So now similarly, same like this, in this case also you can write here. So the angles between the two lines will be here 90 degree. Okay, and you already know that tan theta equals to, now I'm not going to write this plus minus. Okay, I'm directly writing this m2 m1 minus m2 1 1 plus m1 m2. Now from here you will know the condition for perpendicular lines, or perpendicular, it also orthodox also represent this perpendicular lines. Two lines will be perpendicular if you know how to derive that condition. Okay, tan theta, now you write here tan 90 degree. Okay, so m1 minus m2 divided by 1 plus m1 m2. When you calculate this tan 90 degree, something will appear in your calculator, which is sin tax error or whatever. Okay, which means math error, it's just something like that, which means that is infinity. Okay, so now here if you multiply something to infinity, it will becomes infinity. So what you do is you just reciprocal this. What happens if I reciprocal this? Reciprocaling both sides, it becomes 1 by infinity, and this becomes 1 plus m1 m2 divided by m1 minus m2. And there is one thing, something by infinity is equals to 0. Something by infinity is equals to 0. So whatever there will be any numbers 1 2 3 4, any variables 5 6 7 8 9 10, whatever will be, if something is divided by infinity, the resultant will be 0. So I'm going to rub that part. I'm just going to rub this. So this is the condition for parallel lines or coincident lines. Now for these perpendicular lines, I'm going to rub this here. Okay, for this perpendicular lines, now something by infinity means you can write there 0 and 1 plus m1 m2 divided by m1 minus m2. When you multiply these terms with 0, it becomes 0 here, 1 plus m1 m2, or if you move to the other side, it becomes negative 1 minus m2, or m1 m2 is equals to minus 1. So this is the condition for perpendicularity of any two lines. Any two lines will be perpendicular if their slopes, if the product of their slopes is equals to minus 1. So this is the condition for perpendicularity, and this is the condition for parallel lines. So all you have to do in both cases is just you have to test whether the line is parallel or perpendicular. In both cases you have to just first you have to find the slopes of both lines. After finding the slopes of both lines, then you apply this formula for parallelism, and this formula, this relation for parallel lines, and this relation for perpendicular lines. If satisfied, then it is perpendicular or parallel. Okay, so whatever might be the condition there. So and okay, so this much for today. I think you are clear about this. So don't forget to remember this formula. These are the new formula for you. Might be new formula for you, but it's very easy and trivial. But you'll be needing this more in the upcoming exercise that we are going to face. Okay. So by saying it, I would like to end this class here. So in the next class we'll be solving exercise relevant to this exercise. Okay, exercise within the axle of optional math. We are talking about optional math exercise 8.1, and we will be starting from the general, very short questions today, long questions. Let's see what happens. Okay, so by saying that, I would like to end this class here again. Okay, and please don't forget to like, subscribe, and hit like button to my channel. And if you find my video more convenient and more useful, you can circle this video to your colleagues, friend circles, and anyone who might be beneficial from this video. Okay, now until then, goodbye, see you and take care.